Hello, everyone. Today I will present to you my work on controlling stable diffusion for outfit swapping. The problem we're solving now is a consistent outfit swapping problem for image and videos, which is mostly faced in the fashion business. The challenge is twofold. Number one, how to generate a specific item that can change shape. Not any jacket, for example, but a specific design of, say, a spring 2024 Chanel jacket. Number two, how to generate a consistent video of a fashion model moving and posing wearing that specific outfit. Currently, we can only consistently generate specific solid items like a toy or a bag, but not an elastic one. We can consistently change the texture of an off-shoulder dress, but we cannot change such a dress to, say, a long-sleeve jacket. In this work, we personalize a text-to-image generation model, which is a Dream Booth extension on stable diffusion, which is mostly tested on solid items before, but I tried it this time for elastic clothing. I also tried generating videos via three other methods. Number one, in-paint with control-net open pose, which is essentially frame-by-frame, image-to-image stable diffusion. Number two, a tuner video, which is a text-to-video extension. And number three, SDCN animation, which is a video-to-video conditioned by a text. All of them are based on the same item-specific stable diffusion model trained by Dream Booth. There are two classes of related work. Number one is GAN-based models. They deliver good results in specific face generation tasks, but not in more general item-specific generative tasks. And number two is stable diffusion-based models that is better fit for this task. Among textual inversion and Dream Booth, the two tuned models, we tried the latter because it's embedding slides in the output domain. And because of that, it can be more expressive and result in better results when we generate videos that requires a more diverse perspective of the same item. For the dataset, like in the Dream Booth paper, we trained the model with only 3 pictures of the same Chanel jacket from its online store, and then define it as a unique identifier called Chanel jacket, abbreviation jacket. We tried the control net in-paint generation with data augmentation as well, and that indeed improved consistency a little bit. Also to note is that we need a class-specific prior because our training data falls in the class of jacket. Dream Booth generate 1,000 pictures of jackets and use it as a prior. This is to prevent language drift and preserve the diversity of output perspectives and shapes. The math behind Dream Booth is summarized in number 1 and number 2 in technical methods, where the loss is the sum of the expected square distance between the generative sample and real sample, plus the condition vector C trained by our defined item. We also need to add the loss given the prior. Control net is basically directly injecting a condition network, in our case open pose, to the original locked neural network. I won't talk about tuner video and stable diffusion CN as they're less successful, but I'll show you the results. So how do the results look? The Dream Booth is quite successful. If we do a text-to-image generation asking our trained model to generate a Taylor Swift wearing our unique identifier Chanel jacket, the result is pretty much replicates the tweed texture and the design. If you look at even the button and orange lining of the generative pictures, it looks almost exactly the same as the training data. We then use the mean cosine similarity between each 2 frames in the output video to evaluate the video consistency quantitatively. 1 is highest consistency and 0 is lowest consistency. Let's look at the video qualitatively as well to put them in context. This is the original video, and below is the training data. Our video generation used frame-by-frame in-painting, number 1, is successful. The cosine similarity is 0.92, which is very close to the original video, 0.94. But between frame inconsistency can still be very obvious if you look at it qualitatively. Data augmentation improved the cosine similarity to 0.94, but qualitatively it still look not quite natural. SDCN animation, it captures the texture, but not really the long sleeve style. And pretty much preserve only the video's features. Tuner video basically is a low-performing model, both quantitatively and qualitatively. So going back to the in-paint model, control net in-paint model, since we're using in-paint, the process is still a little bit manual, but I believe that the designing, if we define the in-paint area automatically and segment the area by body parts, can help better define the invariables in the generative model and further improve the consistency. This could be the next step. Thanks for listening.